Welcome to the section of machine learning. So let's start what machine learning actually is. Imagine having a student who learns not by following strict rules, but by looking at examples and figuring out patterns. And that's essentially what machine learning does. Instead of being programmed with specific instructions, these systems learn from experience, just like humans do. So for instance, in banking, machine learning systems can learn to spot suspicious transactions by studying patterns in previous fraudulent cases rather than following a fixed set of rules. Before we dive deeper into machine learning, we first need to understand the basic vocabs. So we have there the features, so these are the observed attributes, for example, the data that you know for like the size of the house, the location, and so on, and the labels. The labels, this is the outcome that the model is trying to predict. So the data that you don't know, for example, the price of the house. Giving this table here, so we have then the size, the bedrooms, bathroom location, and so on. What do you think would be then the features if we would like to predict the price? Yes, all of them except of the price. The price would be then the label, so the thing that we're actually trying to predict. Okay, now let's peek under the hood to understand how machine learning actually works, but no worry, we will have a closer look at the whole life cycle at a later section. So again, it learns through data and patterns, which we already know, and there's a process involved. So think of it like teaching a child to recognize different fruits. First, you need good examples. So that's the data processing part. Then you show them lots of different fruits. This is then the training part, so learning from examples. Then we have the evaluation part. So this is then testing the accuracy. And finally, we have the optimization part to help them improve their understanding. And the machine learning system follows a similar process, but instead of using the human intuition mind, it uses mathematical relationships to understand patterns and make predictions. So let's dive into the major challenges that organizations face when implementing machine learning solutions. First, we have the data quality issues. Think of this as trying to build a house with damaged materials. If your training data has missing values or inconsistencies, the model won't perform well. Just like a house built with faulty materials won't be stable. Then there's the classic problem of model performance, which involves two main issues: overfitting and underfitting. Imagine overfitting as memorizing a textbook without understanding the concepts. The model learns the training data too perfectly, including all the noise and irrelevant details. On the flip side, underfitting is like only reading the chapter summaries. The model doesn't learn enough to make accurate predictions. Bias is another critical challenge. If your training data is imbalanced or reflects historical biases, your model will reflect these biases. For example, if a hiring algorithm is trained primarily on data from male employees, it might unfairly disadvantage female candidates. Explainability is becoming increasingly important. We need to understand why our models make certain decisions, especially in sensitive areas like healthcare or finance. It's not enough for a model to be accurate, we need to know how it arrives at its conclusion. And finally, there's a practical challenge of scalability. Modern machine learning models, especially deep learning ones, require significant computational resources. And this means organizations need to carefully balance their ambitions with their available resources, often leveraging cloud services like AWS to manage the costs effectively. So understanding these tensions is crucial for the exam. So make sure you understand the different concepts here. And finally, let's clear up our common confusion. So what's the difference between machine learning and artificial intelligence? So think of as AI as the entire universe of making machines more human-like. And machine learning is there only a specific branch of AI. So AI includes smart assistants like Alexa, which is in the category of NLP. Then we have robotics, we have computer vision, document intelligence, and so on. And machine learning focuses on learning from data and making predictions. That's all for this section, and in the next one, we will explore the different types of machine learning. Thank you and see you there.